engineering destruction, the terrifying and awesome power of the USS Gerald R. Ford. The USS Gerald R. Ford, CVN-78, is a whole new class of aircraft carrier. Officially commissioned by the U.S. Navy and Newport News Shipbuilding Company, the nuclear-powered aircraft carrier represents the first major redesign to a U.S. Navy aircraft carrier in over 4 decades. When a warship is commissioned, it is legitimized under law, and placed in active service for the first time. Replacing what was known as the Nimitz class of aircraft carriers, the USS Ford will spend its first 4 years under scrutiny as builders' sea trials get underway. The trials test crucial systems and technologies aboard the ship, and will cost USD $780 million on top of its USD $12.9 billion manufacturing price tag. There were delays and overruns because of the complicated task of integrating whole new systems and an entirely new class of technology aboard the ship, which was originally supposed to be completed in 2015 for USD $10.5 billion. Designing a new class of aircraft carrier means that expectations for improved performance are going to be set extremely high, and you'll see that the features of the USS Ford make it a true marvel of modern weapons engineering. Interestingly, the USS Ford also appears to be a minor milestone moment for 3D modeling technology, because this is the first ship to be fully designed as a 3D model. The USS Ford has its own nuclear plant inside of it, which generates a consistent and high enough rate of energy that affords the vessel a top speed of 30 knots, 34.5 miles per hour, 55.5 kilometers per hour. Nuclear warships like the USS Ford are designed to be fully autonomous. The amount of nuclear energy produced by the USS Ford means that it could run without stopping to refuel for 20-25 years. Nuclear upgrade. There are 2 A-1B reactor plants. A is for aircraft carrier, 1 is first generation, and B is for Bechtel, the manufacturer, aboard the USS Ford, and they were specially developed by Bechtel for the new class of supercarrier. Bechtel normally handles engineering and construction for nuclear plants in the USA. The A-1B generates almost 3 times as much power as the A-4W reactor plants on the active Nimitz-class carriers. The exact number is classified, but estimates have been made that the total increase in energy is 700 megawatts. Electromagnetic Aircraft Launch System, EMLS, versus Steam Catapult System. The U.S. Navy began experimenting with the design and production of a launch system that uses linear induction motors and electromagnets instead of steam-powered turbines because engineers realized that you could improve 3 things: eliminate the need for housing a separate steam boiler, increase the level of control during jet or drone takeoffs, and reduce the amount of maintenance in 2 ways: using solid-state components and reducing wear and tear on the supercarrier from repeated launches. The reason electromagnetic catapults cause less stress is due to the increased control over acceleration, allowing launches to be more gradual and steady than steam pumping through a turbine. This engineering improvement is interesting partly because it raises interesting questions regarding the safety and reliability of EMLS versus the traditional steam catapult system, which was implemented to replace the hydraulic systems used during World War II. Unfortunately, at this time, it is hard to make comparisons with available data. Flight deck redesign. The USS Ford has a 5-acre flight deck with a smaller island that has been moved toward the rear of the ship, providing more room for airplane maintenance. The weapons elevators are like the new EMLS catapult system in that they use electromagnetic fields instead of cables, and have horizontal doors that also help reduce manpower needs and maintenance costs. The infrastructure is flexible and can be adapted to changes by reconfiguring compartments to optimize for different missions, saving time and money while avoiding the costly rework that would create bottlenecks in the Nimitz-class carriers. Besides the EMLS system, the USS Ford comes equipped with new advanced arresting gear which weighs less than the traditional system, has software controls and requires less people to run it efficiently. Another addition is multi-function radar and volume search radar, a system which combines two radars operating on different frequencies for tracking, airborne intercept, search, target illumination and missile guidance. Designing and engineering more efficiency. The USS Ford is a 21st-century feat of design and engineering. The ability to fully redesign a whole new class of aircraft carrier afforded engineers new opportunities to create new efficiencies. Besides eliminating the steam catapult system and all its steam turbine-powered auxiliaries, the design was also an example of component optimization. Eliminating up to half the valves, 70 sea chests, rectangular or cylindrical recesses in the hull, for drawing and piping water, one hangar bay and one aircraft elevator. The dry docking interval has been extended to 12 years. Air conditioning has been improved across the whole ship, which means less dirt, dust and moisture levels with an amazing total of 9,900 tons blasting through the ship. Steam heating was also ditched in favor of electric water heaters, which has the design impact of eliminating a huge piping network that would stretch across the ship in the Nimitz-class carriers. Light bulbs were upgraded to LED lights for battle lanterns, which increases the effectiveness of each battery on each lantern. The lighting aboard the USS Ford includes 44,000 fluorescent T8 light bulbs, which last about 2 times as long as the previous bulbs. The sheer volume of materials needed to complete the USS Ford is astonishing: over 4 million pounds of weld metal, 4 million feet of fiber optic cable, and 200,000 gallons of gray paint, for example. Internally, to keep its crew alive and well, the supercarrier produces 400,000 gallons of fresh water and 15,000 meals every single day. Armament. Besides carrying over 75 warplanes, the USS Ford has some serious destructive capability. Engineers and designers include a DSSM, Evolved Sea Sparrow missile, RAM, rolling airframe missile, and a Mk-15 Phalanx close-in weapon system. ESSM, Evolved Sea Sparrow missile. These missiles have an incredible ability to protect ships from both missiles and enemy aircraft. 4 SSMs can be packed into Mark 41 vertical launch systems, and fired at complex attacking entities like supersonic maneuvering anti-ship missiles. RAM, rolling airframe missiles. These small surface-to-air missiles are named because it spirals around its longitudinal axis like bullets out of spiraled barrels. It travels at Mach 2.0, has a range of 5.6 miles, costs USD 1 million each, and has a 25-pound blast fragmentation. Mk-15 Phalanx close-in weapon system. This system is also designed to counterattack anti-ship missiles. A radar-guided 20mm Vulcan cannon is the last line of automated weapons defense against attacking aircraft and anti-ship missiles. Incredibly, this automated sentinel shoots armor-piercing tungsten rounds at a rate of 4,500 bullets per minute and is designed to pierce a missile's airframe, rendering it less aerodynamic, keeping shrapnel explosions contained and limiting collateral damage to the crew and the carrier itself. Though it will be a few years before the USS Ford is in active duty while undergoing an array of sophisticated weapons and integrated systems testing, the opportunity to redesign a new class of aircraft carriers certainly afforded ship designers, engineers and mechanics to create a masterpiece of modern naval warfare.